am, after all, only the chairman of the Space, Science, and Technology Committee. So now they've given me a better microphone. Again, I want to thank all of you for participating today, and I want to thank our host, Congresswoman González Colón and Ranking Member Waltz. My friend and colleague here, Congresswoman González Colón, may no longer serve on the Science Committee, but she is still actively engaged in all the STEM issues as we work on them across the floor and in the United States Congress. And I appreciate your commitment to science and technology developments. We've had a great tour of the observatory today, and I really enjoyed our lunch with the local students to hear about their engagement with Arecibo STEM programs that spark their interest in science and technology. It restores your faith in the future of this great country, and for that matter, this world, when you have an opportunity to be with that kind of extremely bright young people. Trips like this are important for members of the committee because it gives us an opportunity to go out into the country, the world for that matter, to see what really matters, to look at how we can oversee and support our nation's research enterprises, including the work of NSF and NASA. In its 57 years, this observatory has been known for truly groundbreaking discoveries. Now, I will acknowledge to you that I'm only slightly older than Arecibo, and I have a few creaks and squeaks a little bit myself now and then, but this kind of a legacy investment is not only a reflection of all that has been accomplished here and the body of knowledge it's added to, but I think it also reflects, as the Congresswoman points out to us consistently and firmly, it reflects an importance of making sure that it has the opportunity to live up to the greatness in the future. And I know Puerto Rico has a long history in contributing to scientific discovery. I'm just proud to be here, Jennifer, and proud to be with you, with our colleagues on the committee, about to listen to a really, really outstanding group of panelists on the forum. And with that, as the hostess, let's turn to my subcommittee chairman, Mr. Waltz.
Thank you so much, Ranking Member Lucas, and I too want to thank Representative González Colón, but also to express to everyone today, and I know we're streaming live and watching, what a fantastic Congresswoman that you have right here in González Colón. Honestly. You know, but even I think before I was elected, she was reaching out to those. I represent Central and North Florida, so the University of Central Florida is right on the edge of my district. I have the wonderful institutions like Embry-Riddle University and Daytona State and 5 other universities in my district with Daytona that runs from the northern border of Cape Canaveral up to the suburbs of Jacksonville. And I was going to say, when I was even a candidate, Jennifer was reaching out. She wanted to be sure that Puerto Rico's priorities and needs were understood by anyone who was even thinking about representing that part of Florida. And my predecessor is now our governor, Ron DeSantis, who was a real advocate for Puerto Rico as well. But you know, today is also just about science, and it's about research, and it's about technology. And I sought the Science, Space, and Technology Committee. I'm a space nerd. I'm proud of that. And you know, we were just with the students today. I have to tell you, I felt a little bit dumber coming out of that because they were just so sharp and impressive. I don't know what the heck I was doing at 14, 15, but I certainly wasn't doing the type of research that they're doing, but more so really, truly inspired. Truly inspired. We, as Representative Lucas knows, have worked a lot on STEM education packages and incentives, particularly focused on women and focused on minorities. It's a real numbers problem that we have now in the country, we are due to be 1 million jobs short in the STEM field over the next decade for the workforce of the future. Well, we will never make up for that when we have around 27% participation from women and only about 10 to 11% from minorities. So to see that the Star Academy here has 75% participation from women is truly inspiring. And to me, you know, I'm looking at some of them here in the audience, are the leaders of the next generation. So I think I'll just conclude to say that we cannot have the economy of the future, but importantly, the United States cannot maintain its role as a leader of the free world unless we make these investments in STEM. That's not just the hardware and the structures that we have here today, but it's the people and it's the scientists of the future. And so to me, this is a double investment and a double win for the country. And I'll conclude with my favorite saying that we were talking about in lunch, that the United States of America cannot maintain its position as number one on Earth if we're number two in space. And we have to continue to lead. And it is just driving me crazy to know that the Chinese now have the largest fully operational single dish radio telescope. We need to get that back. And I look forward to talking today about how we get that back.
Thank you, Ranking Member. And with that, we turn to another Ranking Member of the Science Committee with responsibility over NASA, Dr. Babbitt.
Thank you very much, Chairman. Really am proud and honored to be here. I just want to thank our host, Jennifer González Colón, and what a great job you're doing. It's so impressive to see how you're loved here. And I tell you, one of the things I really noticed was she always answers the phone. Somebody said that a while ago, one of your constituents. And I also want to thank my friend Michael Waltz for helping get this together, and of course Mr. Lucas. I appreciate that. But I'm Brian Babin, and I represent the 36th district in Texas. So basically, if you look at Texas, a map, it's Houston over to the Sabine River, which is the Louisiana line. And I represent Johnson Space Center. Very, very proud to have our largest NASA facility in my district. And I'm also been very, very honored to be the subcommittee on space and aeronautics chairman. And now we're in the minority, so I'm the ranking member. And it's always been a huge inspiration to me to be involved in our nation's space program. And I've always been really inspired. And I heard our chairman say a while ago that he just was barely around when Arecibo was built. Well, I hate to admit this, but I was already in the 9th grade when this place was built. And so it was, doesn't seem like that long ago, but in reality it was a heck of a long time ago. But amazing what the history of this place is, and the people like Francisco and these students out here, and many of you all that have worked here. Ray, appreciate you so very much, and all of you that are involved in this location, the history of it, and the inspiration that it's created in a lot of these young people. And I was so impressed with these young folks at lunchtime as well. Like Michael said, amazingly, we have to have 16-year-old kids, and I hate to call you a kid because you have your head screwed on right. Many 16-year-olds don't have that, and you know, I tell you, I really worry about the education gap that this COVID pandemic has created in our country, and it's so refreshing to be able to see and talk and meet young people that are studying online. I asked them where they were doing some of their internships for NASA and online. And that's what many of our kids have been doing. And I'm just hoping and praying that we don't have that major education gap that will harm us and cause us to fall from being first in space, the #1 spacefaring nation in the world. Because as we've heard several times today, if you're number 2 in space, you're going to be definitely number 2 or less on the surface of this planet. So we're here on a fact-finding trip, and I've already found out a lot of facts that really didn't know. My introduction to Arecibo, besides reading about it, was contact. And anyway, I'm and Goldeneye was another one. But I really appreciate what Arecibo means, and it's so it's eye-opening to me to hear what it means to Puerto Rico, and what it means to your history, and what it means to the inspiring of your young people to go into STEM studies and become doctors and engineers and astrophysicists and on and on and on. And anyway, thank you, Steve. Too late now. I'm winging it. Anyway, we really appreciate all of you. We want to see the best happen for our nation and the best happen for Puerto Rico and the people here. You know, with the failure of this thing and the sadness of losing it, it was really a tearjerker for me as well to see grown men start shedding tears as they talked about the history of this place. So I'm looking forward to getting some answers to some of these questions that we have. And again, thank you, Jennifer. I really appreciate you hosting us, and Michael for putting this together. And Chairman, I'll yield back.
Thank you, Ranking Member. And once in a while in one of these congressional forums, you have kind of a special guest, a unique individual who may not necessarily at present be an authorizer. We have a colleague from Mississippi, Congressman Palazzo, who is an appropriator. And to my young scientist in the room, we help drive the policy, but he writes the checks. So it's important that we have an appropriator with her. And we're especially lucky today because our appropriator, Mr. Palazzo, before he went over to be on the Bunny Bags Committee, was chairman of the Space Subcommittee on the House Science Committee, correct? How many years?
That's correct, 5.5 years. Yeah. Well, Chairman, thank you, and to Representative González Colón, thank you for the invitation. You know, we talk a lot about our committees, and that's what a lot of people see when they're watching us on C-SPAN, but I have to tell you, one of the greatest things about serving in Congress is the relationships that you can build, and everybody on this panel are, you know, just fantastic members of Congress, and I consider them my friends. But I have to say, there's no better advocate and stronger supporter of Puerto Rico than my colleague to the right of me. So she does a fantastic job. And personally, I thought I was being invited on this CODEL because of my former status on the Space Subcommittee. But obviously it was because of my appropriation status that I'm on now. But I am on the Commerce, Science, and Justice portion of the Appropriations Committee. And, you know, I got to tell you, this is my first CODEL since COVID. And it's great. It's so important for members to get out and conduct oversight. I would have never known anything about the Arecibo Observatory or the problems that you're having because we get so many things thrown at us when we're in Congress. And so these CODELs are extremely important, and to be able to go back and actually advocate and support the mission that was here and whatever future mission is going to be here, it's all because of a direct result of this CODEL and invitation from Jennifer. You know, there's been a lot of talk about infrastructure. You know, there's been some new definitions of infrastructure, which people are trying to spend trillions and trillions of dollars on. But this is true infrastructure. What y'all have here is a national treasure. And it needs to be protected, it needs to be supported, it needs to be well funded. Because, you know, we do have a shortage of PhDs coming out in America, but our adversaries have no shortage of PhDs. And, you know, people pursue the STEM field. It's almost every one of the students that we talked to today, they had a story of inspiration, and their inspiration was derived from being physically present here and engaging with the people and the scientists that were here, and that's propelled them to pursue STEM education. And by the way, I agree. I mean, I picked up a pre-algebra guide in there just because I feel so dumb after talking to these young people. And of course, Dr. Babin picked up Algebra 1 and 2, so I guess I'm in remedial. But it is good to be here. And, you know, I'm proud to represent Stennis Space Center in my district. And when you look at NASA and NSF and how they spread these national treasures out throughout America, it's important because not one state, not one congressional district should have those assets and resources, because we need to be able to inspire the next generation of scientists and PhDs and educators from all across America. And so, you know, we need to invest in the future as if our lives depend upon it, because it truly does. And it's just an honor to be here, and thank y'all for coming out to support this panel.
Thank you, Congressman Palazzo. What can I say? We now turn to a member of Congress who managed to persuade 4 other members to get on planes at varying times yesterday evening and late last night to come spend the Saturday afternoon discussing the things that are important, that matter not just to the community here in Puerto Rico, but to the scientific community across the nation and around the world. I think that's really an impressive accomplishment. But with that, let's turn to someone I just simply referred to as my friend Jennifer.
Thank you, Mr. Chairman. I really appreciate having Chairman Franklin Lucas from Oklahoma visiting the island and actually helping us out. When the collapse of the observatory happened, we immediately communicated with him and his office to write a letter in terms of to the National Science Foundation, what's going on, what's going to be the situation, and immediately he drafted that letter with the chairman of the committee at the time, requesting action and even doing a press release from the science committee in a bipartisan way. And I reached out to Stephanie Murphy as well, and we included language in the appropriations committee to get reports on what was going on, and that was even before the second collapse happened. So for me, being here is as we were speaking this morning, it's one thing reading about this and a completely different story being on site. And I understand my colleagues here now get a different impression of what we're talking about. The Observatory of Arecibo is not just a plate, it's not just a site, it's where science and life experience happen. We just got lunch with a group of leaders, I need to say leaders, from not just high school and university level, to share their experience with us and how this place impacted their life in terms of studying STEM. And for me, having a group of young ladies focus, knowing what they want to do and how successful they are in their achievements, as well as the gentleman that with us today. It's a great example of what can be done if we put the money and the resources when we need it. I want to say thank you to my friend Mike Waltz as well, ranking member from Florida, for coming up and being in communication with me all these months to make this happen. It was first in June and then in July, and finally we got it. I'm a little bit persistent, I know. I want to say thank you to my dear friend Brian Babin as well from Texas, that immediately understood what we were speaking about, and he got his own science side in his district, so he understands this perfectly. Palazzo, this is not the first time he's coming, but I'll say it's important not just because of appropriations, because he's a friend. And every time we are on the floor of the House, the first question he's asking, what do you need for Puerto Rico? How we can help. And that's the way we build relations to get things done. So I want to say thank you to them, but I want to say thank you also to the Arecibo Observatory for organizing this. A complicated agenda with the COVID restrictions, and Francisco Cordova has been doing an amazing job with us to coordinate this. I want to say thank you, and your staff, as well of all the people and staff from all members of Congress to get this done. And I want to say thank you as well to the district representative, Memo González, that is with us and was sharing. This is his district. And I want to say thank you to the mayor of Arecibo as well for his comments yesterday supporting this initiative. I want to say thank you and welcome to everybody this afternoon. Foundation Angel Ramos, that is one of the biggest sponsors of the project, as well as the people from the academia and students. I think just for the record that we need to say that Arecibo is a multidisciplinary facility that supports research on the fields of radio, astronomy. For those people watching live right now, I need to say this, and I'll say briefly in Spanish. Radio astronomy, space and atmospheric science, and planetary sciences as well. For multiple decades, the 305 radio telescope housed in this facility was the heart and soul of the Observatory of Arecibo. Provided the advancement for scientific research, STEM education, foster multiple discoveries, and help us better understand our planet and the surrounding universe. It was an engineer marvel and an instrument known before I was born. Just to lay that out. And it's treasured, still is treasured by Puerto Ricans as well as students, researchers, and visitors from around the globe. Following the series of cable failures back in August and then in November, despite the work being done to stabilize the structure, we lost the radio telescope on the morning of December the 1st. And after the 900-ton suspended platform sustained an uncontrolled collapse. And I know many people here remember that day better than others because it's a change in the whole history of this area. That day, of course, is the reason we are here, why that happened, how we can stop that thing from happening again, and how we can improve the use of the Observatory of Arecibo, because this is still a life work in progress. We have a community that have a sense of culture cultivated by generation of scientists and students that have walked these halls and brought life to this facility. The collapse gained national and international recognition as the scientific and local community lamented the loss of that radio telescope. And yet, the facility remains, and this site continue to produce science, foster research and students, and inspiring generations to come and providing new STEM professionals. And that's the reason this is the forum, of Arecibo Observatory, a bright future ahead. And moving forward, we need to understand first why it happened, what happened with the collapse. Second, what are the avenues, what are the opportunities that lie ahead for us, and how we can better do that than having the top researchers and the people leading that effort for the cleanup and managing the observatory, and that's the panel we're going to have now. We have assembled a group of witnesses who will provide testimonies related to the facility and to help us understand potential avenues for the observatory. And I need to say this briefly in Spanish for the people that are looking to us live stream. Bienvenidos al Observatorio de Arecibo. Para mí es un placer liderar un grupo de congresistas del Comité de Ciencias, Espacio y Tecnología de la Cámara, que vienen aquí, no para hacerlo por internet, sino aquí literalmente a ver lo que está pasando, cómo fue el colapso, cómo podemos ayudar, a ver qué tecnologías se pueden incorporar aquí en el observatorio para que siga siendo un lugar de investigación, un lugar donde promover la educación en las áreas de ciencia y tecnología, y que estos miembros del Congreso hayan sacado su tiempo para venir hoy a hacer una visita de todo el área de Arecibo, específicamente el observatorio, y ver qué oportunidades tenemos no solamente en la asignación de recursos, en hacer la supervisión de lo que ocurrió, pero también coordinar con el Science National Foundation de ver cuáles son y las universidades que manejan esto. Así que esta colaboración y este foro que vamos a llevar a cabo trae las mentes más privilegiadas sobre qué pasó, cómo se está limpiando, qué oportunidades tenemos y cuáles son las propuestas que tanto la academia y el Observatorio de Arecibo ha estado impulsando. Mi labor en el Congreso es buscar cómo aunamos esos esfuerzos para hacer que pasen. Así que les agradezco a todos que estén aquí, aquellos que están conectados van a ver más información sobre esto y documentos que hemos redactado para esto a través de las redes. Having said that, it was very briefly in Spanish. I will like to introduce the panel for today. First of all, we got Mr. Francisco Cordova, our first witness, And I thank you again for all your wonderful job. Mr. Cordova is Executive Director at the Arecibo Observatory. He holds a bachelor's degree in civil engineer from the University of Puerto Rico, Mayagüez campus, and a master's degree also in civil engineer from the University of Michigan in Ann Arbor. Mr. Cordova is the youngest director to ever lead this site, managing a team of world-renowned scientists and engineers performing cutting-edge research in astronomy, atmospheric sciences, and planetary sciences. Our second witness is Mr. John Abruzzo. Mr. Abruzzo is the managing principal and forensics practice leader at Thornton Tomasetti. The engineer of record is the engineer of record for the stabilization and remediation of the telescope. Mr. Abruzzo holds a bachelor's degree in civil engineer from Villanova University and a master's degree also in civil engineer from the Stevens Institute of Technology. He's known for work that includes investigating structural failures, deconstruction engineering, and emergency response. Our third witness today is Mr. Luis Quintero. Ms. Quintero has been the manager of the electronics department since 2012 and holds a master's degree in electrical engineering from the University of Puerto Rico, Mayagüez campus, and a bachelor's degree in physics engineering from the Universidad del Cauca in Colombia. Our fourth witness is Dr. Alison Smith. Dr. Smith is a permanent postdoctoral fellow in the radio astronomy group at the Arecibo Observatory. Dr. Smith holds a PhD and Master of Science in Physics from the University of Georgia, Athens, and a bachelor's in astrophysics from the Agnes Scott College in Georgia as well, where her interest in radio astronomy began. Our sixth and last witness is Dr. Carlos Padilla. Dr. Padilla holds a PhD in Geography, in Planning and Natural Resources Management, and a Master in Science in Environmental Studies from Southern Illinois University. He also holds a Master in Environmental Planning and a Bachelor of Science in Mathematics from the University of Puerto Rico. And he is the co-principal investigator for education program and outreach at the Arecibo University Observatory. Having said that, now we're going to begin with the introduction from the National Science Foundation. So I please welcome Dr. Robert Smith to take the podium. From the National Science Foundation, we have Dr. Robert Smith, Acting Division Director of the Astronomy Division in the Math and Physical Sciences Directorate, who will deliver his remarks and provide an overview of the Arecibo Observatory Options Workshop conducted in June of this year. And Dr. Smith received his bachelor's degree in astronomy from Indiana University and his PhD from Harvard University. And after his remarks, we will hear from our panel. Good afternoon, and thank you. Go ahead.
Thank you, Representative González Colón. And on behalf of the National Science Foundation, there we go, I would like to welcome all of our distinguished guests, of course, including those from Congress, as well as all the local authorities we have in the audience here, and all of you today. Arecibo Observatory is a major multi-user research facility owned and funded by the National Science Foundation with congressional appropriations. The observatory is part of NSF's broad portfolio of federally funded facilities. In its long history, Arecibo has had a wide range of scientific capabilities and contributions. As Representative González Colón mentioned, in supporting radio astronomy and planetary radar with NASA's help, as well as atmospheric and geospace sciences. The observatory is also well known for its outstanding education and outreach programs. I know we have several people here with us today that were influenced by these, have been recently influenced by these programs, and indeed were influenced by these programs in their younger days. Indeed, the person in charge of this facility for NSF, Dr. Alison Smith, was a student here in the 90s. And her story goes from being a student here, a student intern, to being astronomer at various facilities, NSF facilities around the world, including ALMA in Chile, including the Gemini Observatory in Hawaii. So that's the sort of trajectory, one of many trajectories that the students you've seen here today have in store. And that's the sort of investments we look forward to continue making with our partners from Congress, as well as our partners here in Puerto Rico. For the past 3 years, our partner, the University of Central Florida, as well as Yang Enterprises and La Universidad Ana G. Mendez, have been responsible for operating Arecibo for us under a cooperative agreement with the NSF. Unfortunately, as we've seen from the tour and from the platform outside, following a series of cable failures in late 2020, the 305-meter telescope instrument platform collapsed into the dish on December 1st. NSF's primary focus from the first cable separation and through today has been the safety of personnel here and the site. Since the collapse, our priority has been on cleanup and environmental protection to ensure that the site is brought back to a safe and stable state for all personnel and for operations of the remaining facilities. Some AO facilities, including the LIDAR facility, the 12-meter telescope, and Culebra Station, were not damaged during the collapse and are being or have been brought back into operations. We are looking forward to the moment that this building, the Angel Ramos Foundation Science and Visitor Center, can resume its important task of educating and motivating the young scientists of tomorrow. Looking forward, NSF has begun evaluating a broad range of options for the future of Arecibo Observatory. To do this, we are engaging diverse communities in an open discussion of ideas and possibilities. One important step in this discussion is a workshop that NSF held through multiple virtual sessions during the month of June. More than 100 community members spanning a range of ages, genders, professions, and backgrounds registered and participated in this event. These included participants from observatories and educational institutions in Puerto Rico and beyond, and also individuals from various walks of life who have spent time here at the observatory in their early careers or have even grown up here. Using a unique interactive platform, this workshop allowed for participants to meet virtually without having to travel, therefore lowering barriers for participation, to brainstorm, to discuss novel and innovative ideas in groups, and to form collaborations to further develop these concepts. Participants were particularly encouraged to think about the intersections of science, of engineering, and of STEM education outreach, and to explore ideas that will bring people from these various fields together in support of the future and to learn from each other. The outcomes spanned a wide range of concepts, from cutting-edge technological concepts to multidisciplinary research centers, which would develop the human resources on the island, fostering community engagement and building closer collaborations with academic institutions on the island, throughout the U.S. and Latin America, and throughout the world. At present, there are many exciting ideas, and the NSF is encouraging the teams from the workshop and others to develop their ideas into proposals that can be acted on. At this time, no one option or idea is currently favored by NSF. We're looking for those proposals, and all proposals for these future activities, whether developed through the workshop or independently, will be reviewed following the formal proposal submission and review process, using the two fundamental criteria in place for the consideration of any NSF proposal. Number one, the intellectual merit. How does this proposal contribute to forwarding our understanding? In this case, often our understanding of what's going on in our atmosphere, what's going on in the universe. And second, broader impacts, the potential to benefit society, the potential to grow everyone's knowledge of the universe, to grow society's involvement through STEM education and outreach. We're looking forward to receiving and reviewing these proposals, and the NSF is committed to partnering with the people of Puerto Rico and with our congressional appropriators and authorizers to ensure a bright future for Arecibo.
Thank you to Dr. Smith, and I appreciate that during the situation of the collapse, we got a conference call with Dr. Panchanita and his staff to, one of the concerns at that time was the cleaning of the site. And after, the chairman intervened and members of the committee receiving the notification from NSF that the organization will be responsible for the cleanup of the area was quite important because we do know the cost were too big to be handled by the local government. So thank you by that. Now we're going to have, first of all, I want to recognize the people from the University of Ana Jiménez that manage and are great collaborator of the Arecibo Observatory, as well as the University of Central Florida. I want to say thank you as well to the people from Jang Enterprises that supports this radio telescope, and the Foundation Angel Ramos that helps to manage the visitor centers. So having said that, now we're going to have Mr. Cordova, Francisco Cordova. You are now recognized for your remarks.
All right. Good afternoon, everybody, and thank you, Congresswoman González Colón, for your great support throughout the entire process. You've always been an advocate and a believer in this facility, and it really shows the fact that we're here today. Thank you very much to all the members of Congress that took out of their time to participate in this visit, to learn a little bit more about the Arecibo Observatory and understand its importance to the international scientific community and to Puerto Rico. And so today, I'll start by talking a little bit in general about the observatory for those of you that perhaps weren't as familiar with it. The observatory is a multidisciplinary research facility. Then we focus our science and research efforts in three particular areas, and those are radio astronomy, space and atmospheric sciences, and planetary sciences. Until very recently, we hosted the largest single distributed telescope in the world, along with the most powerful planetary radar in the world and the most powerful incoherent scatter radar in the world. We also have one of 4 ionospheric heaters in the planet, and only the second one in U.S. soil. Here at the site, as it was mentioned, this is a National Science Foundation facility built in the 60s, originally by the Department of Defense, focused really on monitoring what at that time would have been either Sputnik or other ICBM satellites that could be sent from Russians in the middle of the Cold War. Right now, the facility is really purely a research facility. We do have over 130 staff members from 11 different countries, so quite a diverse group of scientists, engineers, researchers, and support personnel. And the facility is really also known for incredible accomplishments. And some of these are a Nobel Prize in Physics for discovering the first binary pulsar, the first exoplanet, the first planet outside of solar system was discovered here at the Arecibo Observatory as well. The first message sent to outer space was sent from the Arecibo Observatory as well. And so a lot of scientific accomplishments. Why is this facility important? Well, our science allows us to do a lot of different things. One, we get warning from hazardous asteroids, or potentially hazardous asteroids. We're basically the only facility in the world that can give us enough warning time if a potentially hazardous asteroid were to come, so that we could act on it. All right. It is also a powerful discovery tool. Right. The amount of discoveries that have been made here, again, from a double binary pulsar to the first repeating fast radio burst, that has been done because of the capabilities and the sensitivity that this facility had. We are also one of the few facilities in the world that have over 50 years. We have long-term data trends of atmospheric research. And that is very important for us to understand space weather, for us to understand climate change. And of course, we've mentioned the importance of STEM education and the inspiration for future generations. Unfortunately, on December 1st, 2020, we had the collapse of the platform after months of struggle with the structural failures of some of the suspended cables. On August 10th, we had the first failure on our auxiliary cable, and then on November 6th, we had the second failure of a main cable, resulting in the collapse on December 1st of 2020. The video that you're seeing was taken from one of the Arecibo Observatory drones, who at the time just so happened to be inspecting those cables. We did inspections around that time 3 times a day, and we're lucky enough to have that particular drone up in the air at the time of the collapse. So what has been the impact to U.S. capability? Well, it's been significant impact. Right now, we don't really have another radar, planetary radar, that is powerful enough to help us characterize and predict the orbit of potentially hazardous asteroids. The only other planetary radar available is the Goldstone radar in California, and it only has about 10% availability and about 45% of the power that we had at Arecibo. Similarly, we have no other incoherent scatter radar at this latitude that can help us continue to collect long-term data in order for us to understand better climate change. We have since stopped collecting critical data that can really help us into the future. And third, we've really diminished our capability to discover new things, right? The radio telescopes are really used as discovery tools. Sometimes we don't really know what we're looking for. We're just listening to see what we can find. And unfortunately, the fact that we don't have this time available for that has significantly diminished that. In addition to that, now we have other issues, competitiveness issues, right? China now has the largest and most sensitive radio telescope in the world, and China's fast. They have an ISR as well in this same critical latitude that we used to have it, so they are collecting atmospheric data when we weren't. Europe has now the most advanced incoherent scatter radar in the world with ISCAT 3D, and have also heavily invested in the SKA telescope in South Africa that will soon dwarf US VLBI capability. And so from a competitiveness perspective, the loss of Arecibo is significant. And we don't really have another telescope or another facility that can replicate the capabilities that we had before. And so what have we done? As soon as the collapse happened, we really had to shift our focus internally as a team to make sure that we're continuing to do value-added science to the pieces of equipment that we did have available. Okay, and so from short term, we developed quick short-term, medium-term, and long-term goals for the facility. The short-term goals focuses on the 12-meter antenna, which is now been made operational after it had been heavily damaged by Hurricane Maria. We're also making sure that we're processing older data sets with newer technologies. Now we have machine learning and artificial intelligence that can help us really go through some of those older data sets a lot faster. On the SAS side of the house, we have LiDARs and optics facilities that are still operational and continue to do great science. And we are also focusing on data archiving and analysis on the planetary side of the house. We've also made collaborations with multiple other universities and entities in efforts to submit proposals for potential capabilities in the future. Okay, and so we've partnered with the University of Puerto Rico at Maya West, we've partnered with Universidad Ana Jiménez, Universidad Interamericana, and we submitted a range of proposals that can give us some midterm capability. But our real big focus has been on what are we going to do in the long term. And so we developed a white paper in conjunction with several members of the community and developed a concept for what would be the next generation Arecibo telescope. Now, this particular concept that we've developed, we wanted to make sure that wasn't an evolutionary leap forward, that it would be a revolutionary leap forward. And that, as Bill Gordon said when it originally was created, when the original Arecibo Observatory was created, if you're going to think, you better think big. And we're thinking big. And so our current concept would provide the highest sensitivity on the planet for a next generation radio telescope, and it also would provide more than 4 times the amount of power for our planetary radars and incoherent scatter radars, as well as an increased sky coverage of over 250% and RFI cancellation technology. So what do we get with something like this, with a concept like this, right? And of course, you have to refine the concept and mature the concept in order to make it a reality. but we would be able to basically get warning from a potential dangerous asteroid up to 7 months of warning time. So 7 months, you can actually do something about a particular potentially hazardous asteroid. With 3 weeks, there's not a whole lot you can do. We could also help deepen our understanding of climate change and space weather as well. We can help detect exoplanets, right, and the atmosphere of exoplanets that can help planet habitability. And we can also continue our areas of studies in gravitational wave astronomy and dark energy. Operationally, we can do space debris monitoring, LEO and geosatellites monitoring, RFI cancellation, and also supporting missions for landing sites into the future. Of course, education continues to be a critical column for us. We will continue expanding our STEAM education hub and informal education programs here at the site as well. And so, just to close up, the observatory has been a critical research facility for over 60 years. There are no other instruments in the planet that can do what Arecibo did. There isn't a suite of instruments that could do what Arecibo did across multiple facilities. And so right now, I think we have a difficult decision. We're in a difficult position because we have other countries that are investing heavily in technologies that we used to lead and we no longer lead. And so I think this next generation concept, while it needs maturity, certainly it is a concept, it can really help us retake leadership in the field and strengthen space defense and continue to serve as inspiration for future generations. Thank you very much.
Thank you, Francisco. Always wonderful, and thank you for sharing with us. Now is the turn to Mr. Abruzzo. You are now recognized for your remarks.
Okay, good afternoon, and thank you. I feel honored to be here at this panel. I guess, so I'll be telling you as best I can at this point in time, and it's still a work in progress of what happened and why it collapsed. And I put together a few slides to do that. 5 minutes is not enough time, but we'll see what we can do. But before we get started, I do want to say one thing, and that is that we got involved in August when this was a crisis, and I can tell you without a doubt that Ray and Francisco have been the best clients to have in a crisis management situation, and NSF supporting them. It was tremendous, and it's been tremendous even through the cleanup, so thank you very much. So to get started, this is, you've seen it now, this is a model of the the telescope, right, the platform. We developed this because this really helps us understand the geometry and the structure. And some things I want to point out here are the cables. You can barely see them, but they are visible there. And this is going to stop very soon. But Tower 12 is facing north. That's up here. So this would be the Tower 12 side. The cable that failed first is this one here, going to Tower 4, and then eventually the cables here. There's a series of 4 of them failed one in November and then the others in December. So that kind of puts it into perspective as to what really went wrong up there. And that got us focused on cables, right? We're not as concerned about the structure. And I will show you another video of the collapse. This was taken from the control building, and you can see the cables going to Tower 4 giving way, and the platform swinging down, the feed arm dropping, and the platform coming into the mountainside, and then the tops of the towers collapsing. So it created quite a problem in terms of cleanup. The top 60 feet of Tower 4 fell, which is, I think, approximately 200 tons of concrete. The top 60 feet of Tower 12 fell, just missed for the most part, the visitor center. And then the top 120 feet of Tower 8 fell and did considerable damage, each of those, when they hit the ground. And then you had thousands of pounds of cable land on the structures of the learning center and the scientific office. And this was the video that Francisco showed. This was taken from the drone. And this tells you also the capability of the staff here at Arecibo. Few people would have had the control, self-control when that's happening in front of them and they're controlling the drone to spin around and see the rest of the collapse. And believe it or not, since probably the collapse of the Miller Park roof, which was one of the collapses I've investigated, most of these big collapses, we have video now showing us at least part of it. And it is a significant improvement. It does help us narrow down significantly, right, the things that could have gone wrong. So I'm going to stop this now and move on. So one of the things that we do, of course, is we need to build models, mathematical models, so that we can understand and evaluate, right, the way the structure is behaving. So in the upper left, we want to see the load effects of wind on the structure. It's very important to us to understand how this structure behaved in hurricane-force winds, okay? And did they have something to do with the failure? And it's an accumulation of these hurricanes and of high winds that could build, right, to the point where the structure fails. And so the upper left is what we call a computational fluid dynamics model. Just it allows us to basically convert wind to forces on the structure, and then we can incorporate them in our structural models. So on the bottom here is one of our structural models, which shows the platform, the towers, the cables, and allows us then to convert those load effects like gravity, wind, seismic excitation. So in the upper right, we have this is just a visual aid for us, but the idea is that we can actually generate, right, earthquake seismic motions below ground, propagate them through the soils, and actually determine, right, in space and time, right, when these towers are affected and how that affects the structures. And so we have done a lot of that work to better understand the effects or the impact over the years on this structure. And I guess for the record, I was born when this was just built. So I hope I live a little bit longer than this, last a little longer. But frankly, I didn't feel that the structure was that old for some reason. This gives you a sense. I know many of you saw the cable. This is one of the samples of the cable. This is a 3 5/8 inch diameter cable that went from the tower to the anchorage. And you can see now what how these wire ropes are configured, because this is where we're going to focus our investigation, is on the forces that are in these wire ropes, how the wire ropes behave, and now more importantly, we're finding how those wire ropes are anchored themselves into what we call sockets. And so it's not a simple, even the wire rope is not a simple structure. The wire rope is a wound system of individual strands of wire that are wrapped in a certain orientation, and they basically go in opposite directions at each layer and become a built-up unit, right? And so the assumption in design generally is that the forces are distributed uniformly in these wires, but that may not be the case, and that is something that we need to explore. This is the top of Tower 4, where you can see where the original cable in August, the first cable that failed from the auxiliary system, the system built in the 90s, pulled from the cable. And that was a very unusual failure. And this is the inside of the socket once it was retrieved, that you can see the wires basically pulled out. Some pulled completely out, some failed, stayed embedded in the zinc. And you can see the zinc here and the steel casing. NASA and Wisjani were looking at this socket once we removed it from the site, and they cut it open. And so this, you can see, is a cut, right, or a section of what that socket looked like. And you can see it was a very complicated, actually, failure. Part of it extruded out or pulled out, and part of it stayed embedded, part of the rope stayed embedded and fractured. And they found certain significant things. And one of them is a casting defect here. And also something that Francisco described right when we were looking at the cables, and I'll talk about it in another slide, is the brooming. How well the wires were distributed once they enter the end of the socket here and the rope gets extended up, it gets splayed outward. And how well they broom that really does have some impact on how well that socket will grab. Now, all of these auxiliary sockets that were delivered, right, a series of them were sent in 1994 to Lehigh University to be tested to failure. And all of those failed just as they expected. In fact, higher than the breaking strength that was specified for the wire rope, and they failed in the wire rope, which is typically how these ropes fail. And I should say rope assemblies, because when you order rope with a socket on it. So the manufacturer basically puts the sockets on, you specify the length of rope that you need. This is the piece of cable that was in that socket, right, that extruded through. And this, it's obvious to us when we look at it, we see and we start questioning the brooming. How well distributed or pulled, separated were those wires, because they look that they're clumped down the middle. This is the way the wires should really be broomed. And you can see in a socket, right, they would appear like this, some up against the wall, basically all splayed out. Now, that said, this is a smaller wire rope system. These are very large wires on these ropes, so it's not as easy to broom them out. This is another section of another socket that we removed from the structure. This was one of the backstay cables from the original. That was actually, that was going from, that basically comes in and comes into the socket here. Okay, so you can see the socket on the outside, or actually this is the zinc on the outside. The socket's been removed, it's been separated from the socket. And you can see kind of a depression here, right, like a caving in. And some of that is the fact that the rope does, over time, kind of pull through the socket, a small amount. This is the M44 rope, essentially end of it, the socket. This was the one that actually failed in November. And it failed, at least it appeared to fail, in the wire rope itself, just outside the socket. But what we were seeing once we cut this open was that there's a significant depression here. Right? You see a lot of deformation, you see some slip occurring here. So in effect, this was also really a socket failure, right, which then caused the rope to fail just outside the socket. From the back side of the socket, you could see this collapse of the zinc material, right, from this crater here. So this leads us to this lip that we were talking about. So these sockets, most of the sockets that are out there appear to have this type of structure. They have a lip here, or a shoulder, and then the rope comes through, and it gets broomed out or splayed out. Oops, lost it, splayed out. And then there's another seat or lip on the top, and you fill this thing with zinc, okay, and that holds it in place. The socket that we found, which was more typical that we see and that we specify, looks like this one here. And this socket was a cable wire rope system that went from the tower of the one of the aux systems, so the 1990 installation, but it went from the tower to the platform. So this was the socket that connected it to the platform. And you see there's no shoulder here, right? The shoulder's not there, but there's a groove here and here and here, okay? And that kind of serves the purpose of the shoulder somewhat. And this is typically the socket that, if you find in the literature, is used in the United States. The Europeans actually don't even have these grooves. They just have the conical shape. And so to us, this is something different. This is something that we need to explore. And this is something that we're finding could very well have an effect. We're doing a lot of high-end analysis work, finite element models of this assembly in here, and looking particularly at the stresses here and here, and the difference between this assembly and how they would behave. So to conclude, I don't have basically a conclusion slide on our investigation because it's ongoing. So I don't want to actually conclude too much here today. Other than schedule, I think we're on schedule to provide a draft to NSF sometime in September. We are looking forward to testing one of the socket and rope assemblies at Lehigh University, doing a full-scale test there, and we'll instrument it. It'll run over a few days. We'll announce when that gets scheduled, so if people want to come and watch it, I think it would be very instructive. And at Lehigh, what you didn't mention was I did spend, because I usually don't tell people this, 7 years working on a PhD that I never completed at Lehigh. So I spent a lot of time in that laboratory. I've seen a lot of wire rope in the laboratory being tested. And at Lehigh, when you put something in the machine, it doesn't leave until it's broken. So we will break it to failure at some point. Now, about Arecibo and the future. I must confess, I also only knew of Arecibo from contact, and I saw it recently and realized all the little things in it that actually can't occur, how people drive around on site, but and GoldenEye for James Bond. But I am very familiar, coming from Philadelphia, with how science affects children, and how we had the Franklin Institute in Philadelphia, and how that inspires the next generation to go into math and science, and frankly, to do the basic research that allows the engineers to do the applied research. So it's extremely important that that this facility move forward. As I see it, it's one instrument that's out of service that needs to be put back in service in one shape or form. And I'll tell you, I've been impressed by the number of women working at this observatory and having had opportunities to work here. Our forensics practice at Thornton Tomasetti is inspired by that. My practice leader partner is Elizabeth Malsh, and she has helped me transform our forensics practice to the point where our practice is 40% women. And 33% of those women, I think even more importantly, are in leadership roles. And so I would tell you, they will tell you, that doesn't happen by accident. That happens because we have facilities like this that actually inspire them to go in that direction. So that's what I would have to say today. Thank you.
Thank you, Mr. Abruzzo, and I really don't know how you compromise all those 5 minutes with all that information. Thank you for the great work in that sense. I would like also to recognize some members of my STEM task force. I do have a STEM task force to help. When I was in the committee, I created this with the local universities and people in the private sector. So I want to say thank you to Deborah Maltorel, which is part of the task force that is here as well. People from the Exploratorio, the Universidad Interamericana, and the University of Puerto Rico that are on the auditorium as well. Now we're going to have Mr. Quintero, Luis Quintero. Now you're recognized for your remarks.
There are Congress representatives, NSF, AO staff, students, educators, public in general. So on December 1st, 2020, so the Arecibo Observatory lost this primary radio instrument that allows for 57 years to produce invaluable data in 3 different scientific areas. Also allow us to develop and adapt state-of-the-art technology to the telescope. Also, it serves as a platform for the formation of scientists and engineers, as well as the inspiration of future generations. The 305-meter radio telescope, without any doubt, it has been one of the most productive and relevant instruments in the world. This loss is devastating for the people that work really hard to maintain the telescope. It survived several events, including funding cuts, administration changes, hurricanes, earthquakes, and now recently pandemic. We are resilient and always go ahead of adversity. So we plan to have a renovated instrument by 2023 with Hurricane Maria relief funds, and also with additional proposals like the alpaca receiver. Unfortunately, the structure unexpectedly failed, leaving all those dreams in a pile of debris. Despite of adversities and uncertainties, we continue working to keep the observatory operational, planning for the future, dreaming about the impact on science, engineering, and people with the development and construction of new instrumentation. So I'm going to describe some of the ideas that we have been discussing here internally with the scientific community in terms of short-term plans. But this in some way goes along with the long-term and mid-term plans. So we own a 12-meter antenna, so that's the diameter of the reflector. So it has a limited frequency coverage, and a higher system noise compared with the 305 meter. So there's nothing to compare in terms of sensitivity. But the 12-meter antenna, despite that is less sensitive and is like a smaller pixel in the sky, so still is flexible enough to move the zenith quicker and the azimuth quicker, and also that allows that fast tracking speed to feed other scientific and and engineering applications. So in addition, we plan to expand the 12-meter frequency coverage with a cryo-cooled receiver. So that will improve the system noise, and also we're making plans to automate the data taking processes and interfaces. So with these upgrades, it allows us to have more science cases in astronomy and solar studies, and also enhances the telescope usability. In addition, so we can continue with the Arecibo Observatory radio frequency interference characterization and also mitigation. So one of the ideas also is to reuse the remaining parts of the 305-meter radio telescope, including the primary reflector and towers, so we can reconstruct the HF facility, the heater facility, probably the incoherent scatter radar, and also we have ideas of putting a low-frequency receiver for astronomy, so with some modest investment. In addition, we own and host other scientific instruments at the observatory. We go to the slide. So at the observatory, and also in a remote facility in the Culebra Island. So most of the atmospheric and radio optical instrumentation is in operation right now. And we continue with the plans of making improvements to this instrumentation and doing upgrades. Some of the instruments are complementary to the data that we could take with the heater facility, and also the incoherent scatter radar that we can build in the short term and the long term, for example, with the next generation Arecibo telescope. So we look to the past and we feel fulfilled with all the work performed. Sadly, we can continue our journey with the big telescope, but we desire is to keep our facility optimal and sustainable for years and years and years at the service of the community. Thank you.
Thank you, Mr. Quintero. And now we got Dr. Smith to present.
González Colón. It's a pleasure to be here. So I would like to start by just giving a slight overview. I'd like to start by giving a slight overview of the tremendous scientific legacy of the Arecibo telescope. And then I'll transition into talking about our big dreams for the future of science at Arecibo. So in radio astronomy, the Legacy telescope was a workhorse, for science and radio astronomy in really unparalleled ways. It's known for its spectroscopic studies of everything from the interstellar medium of our galaxy to signposts of star formation, the distribution and evolution of galaxies in our local universe. It also was a particularly important component of the Very Long Baseline Interferometer network. So this is a huge chain of telescopes all over the world that kind of act like one big telescope by taking the light from all the telescopes and networking together and acting like one large telescope so you could study very distant objects in space. And Arecibo provided more than a factor of 5 increase in sensitivity for that. So because of its large collecting area, it was very well renowned for these things and the sensitivity that it provided for these observations. It also was a workhorse for pulsar studies. Pulsars are the highly magnetized stellar remnants of massive stars. And so they're very important for how they, for what they tell us about fundamental physics, essentially. The North American Nanohertz Observatory for Gravitational Waves is a consortium that looks for gravitational waves by studying pulsars. And Arecibo provided more than half of the sensitivity for nanograv. In addition, there are large-scale pulsar surveys that the telescope led, and it's detected more than 300 pulsars, and it's still counting as the data is being processed. So these are just sort of some of the workhorse science that the telescope did, just to give you just a sample of that. It also has a long legacy of firsts in astronomy. Okay, it had the first detection of prebiotic molecules methanamine and hydrogen cyanide. These are critical for building amino acids, and these were detected in another galaxy. It also had, of course, the first detection of an exoplanet, a planet outside of our solar system. The first detection of the binary pulsar, for which the observations were used for a direct confirmation for general relativity. And it ultimately won for that the Nobel Prize in Physics. Space and atmospheric sciences at Arecibo encompasses a huge umbrella of science, including plasma physics, aeronomy, radar techniques for studying the upper atmosphere, and also space weather. The incoherent scatter radar was an instrument mounted on the Arecibo telescope. Okay, the ISR was foundational to space and atmospheric sciences at Arecibo Observatory. You can see in the graph on the right, the vertical axis there shows the layers of the altitude, or the layers of the atmosphere with altitude. And you can see on the right-hand side, on the horizontal axis, various instruments here at AO that Luis actually just mentioned, several of those were just mentioned, are listed there on the horizontal axis. And what the plot's showing on the right side is the altitudinal coverage of the instrument cluster of atmospheric sciences that we have here at AO. And these instruments really work in tandem together to do the science that we do here. The ISR is represented by the gray the bar up in the upper right on that plot. And it was really a workhorse instrument for ionospheric studies. Just to give you a couple of practical applications for the ISR and a couple of results from that, down here at the lower left of the slide, the ISR, when combined with optical data in the instrument cluster, could be used to determine the concentration of oxygen in the upper atmosphere. This is really an important piece of work for aeronomy. It's kind of a holy grail in a sense. In combination with the ionospheric modification facility, otherwise known as the HF facility, the ISR was used to study very rare atmospheric irregularities. And it could actually, this combination of instruments is very useful because it can, in a sense, create these rare irregularities in the atmosphere so that you can study them efficiently and not have to wait for them to occur naturally. So it's a very unique combination to be able to use those two instruments together. And then another very important recent result, very exciting recent result, is the first climatological study of lightning occurrences over Puerto Rico using the ISR. This is actually an REU student project, and it's important because you can see in the plot there in the lower left the island of Puerto Rico, and it's showing basically in the color scale the incidence of lightning occurrences. So you can see the increase in the lightning on the western side of the island. So this is very important scientifically, both for understanding, for example, how lightning affects the upper atmosphere, so scientists can study that. And it's also important, practically speaking, for Puerto Rico because it could assist in future power grid planning. In addition, the fact that the observatory is located here in Puerto Rico is incredibly important and advantageous for us. We have over 50 years of location-specific atmospheric data, and these data are very important because they show long-term trends, essentially variability in atmospheric velocities and temperatures, and this can be used to better understand and assess global climate change. In addition, our position with respect to the location of the Earth's magnetic field means that the Space and Atmospheric Sciences group here is particularly well poised to study anomalies in the Earth's magnetic field that basically cause changes in the plasma in the upper atmosphere. And those changes in the plasma are very important for satellite and radio communications, as well as geopositioning. And given the high transportation traffic that we have here in the Caribbean, that can be very important. Finally, Puerto Rico, of course, is often in the path of extreme weather events, right? Tropical cyclones in particular. And we can study the effects of tropical cyclones on the upper atmosphere of the Earth and also use those to hopefully make better predictions about those events. So the Legacy Telescope was also home to the world's most powerful and most sensitive planetary radar. The radar served a number of different purposes for planetary defense. It also supported spacecraft missions and, of course, produced planetary science. There are just a few firsts listed there at the top of the slide. It had the first confirmed existence of binary and triple near-Earth asteroids, the first radar map of Venus's surface, and also it correctly determined the rotation rate of the planet Mercury. So all of these are very important discoveries, and there's quite a long list in addition to those. The radar was also very important for planetary defense because it was able to precisely determine the positions of asteroids and actually predict their future trajectories and whether or not they would impact the Earth. There are actually more than 25,000 near-Earth asteroids that are larger than 140 meters. These are deemed potentially hazardous asteroids. About 40% of those asteroids have been identified. You can see in the plot on the upper right the occurrences of the Arecibo telescope performing radar observations, and you can see a big peak there in 2012 that's basically following NASA's mandate to track these potentially hazardous asteroids. And Arecibo actually observed successfully over 120 asteroids in 2019. And the radio observations are particularly important for tracking near-Earth asteroids because radio telescopes can do the observations that are required for the orbital refinement in a matter of minutes to hours. So for optical telescopes, that often takes months. So it's a very useful thing to be able to do with a radio telescope because not only could we categorize the orbits of, provide the data to categorize the orbits of all of these NEAs, but we can also quickly rule out false alarms if there would be an impact alarm. And also, instead of knowing the orbit for the next few years or the next few decades, we can actually determine, we can provide the data to determine the orbit for centuries. In addition to planetary defense, the planetary radar also supported various spacecraft missions. The planetary radar was able to provide physical information like the size, the shape, the rotation of asteroids, and that's very important for example, mission planning. If you want to decide which asteroid do we want to go to, where do we want to land on it, the radar observations are very useful for that. And two examples of those types of missions are NASA's DART and OSIRIS-REx missions. If you look at the figure in the lower right of the slide, it shows the radar shape model of the asteroid Bennu, which is the target of OSIRIS-REx. And just beside it is the actual spacecraft image. So you can see the likeness there of the radar shape model to the spacecraft image and how that could be useful. So I hope this gives just a sense of the incredibly important science that we do here at Arecibo Observatory. The collapse of the Arecibo telescope has certainly had a tremendous impact on all of the fields that we study here. And in the wake of the collapse, we are trying now to look towards the future and think about what comes next. And what we really envision is a new instrument, a new telescope that's multidisciplinary and also state-of-the-art. So we've tried to approach sort of the idea of moving forward and thinking about what's next by outlining a set of scientific goals that we think will be important in the coming decades, that'll really be revolutionary, not evolutionary, as Francisco said. So in order to achieve the scientific goals, there are a few improvements that we want to make in terms of our technical capabilities. I'll just summarize the capabilities down in the bottom left. These are essentially requirements of all three groups in order to sort of push forward the science that we were already doing. So we'd like to be able to still do all of the same science and then exceed that. And so in order to do that, we'd like to achieve a larger collecting area. Okay, so greater sensitivity is provided by the larger collecting area of the telescope. We'd like to increase the transmitter power for space and atmospheric sciences and also planetary radar. And would also like to increase the sky coverage, right? So the legacy telescope couldn't point. So we'd like to be able to look at a larger area of the sky. So those are some of the requirements that we think we need to meet in order to achieve the science that we want to achieve. We also believe that it's very important that we have a multidisciplinary telescope here as we have for so long. It serves a lot of purposes, including we'll serve all three of our scientific communities at once. There are several of these science goals that I'll point out that are going to become more important in the future, not less important in the future. We'd also like to maintain our kind of tradition of global collaborations and training future STEM students, which are certainly, as we have seen, attracted to a world-class multidisciplinary research instrument. And finally, we know that multidisciplinary instruments can lead to interdisciplinary science. So it's really the overlap or the interlacing of different fields of science that lead to exciting new discoveries sometimes, and also important capabilities. In the bottom right of the slide is an image that was taken here, that was produced here recently at Arecibo, and it's an excellent example of an important capability to have. This is a result from a space weather study that was done with the Arecibo telescope. And what it shows in the very right of the image is an optical image of a coronal mass ejection, a huge ball of magnetized plasma from the sun. And in the left side of the image, what it shows is the detection of that coronal mass ejection with the Arecibo telescope. So the Arecibo telescope was able to use radio scintillation to track this coronal mass ejection from the sun in between the Earth and the sun as it was on its way towards the Earth. Okay, so this is very important because we have spacecraft that can image CMEs at the location of the sun, and we have detectors that can detect them here, but the region between those two is incredibly important because a lot of changes can happen to the plasma in that time. And these types of observations can actually provide a lot of advanced warning for the arrival, not only the arrival, but also the characteristics of the CME before it gets here. And that can be incredibly important for protecting sensitive electrical components on satellites, even astronauts in space, and in the worst cases, the power grid. So I'll end here by leaving you with a list of the science cases that we hope to achieve, the scientific goals that we hope to achieve in the coming decades. In planetary radar, just to highlight one, would like to be positioned to contribute to space situational awareness. This is certainly going to become an increasingly important problem in the next several decades, being able to monitor space debris. And the capabilities that we're shooting for would enable not only monitoring of even millimeter-sized space debris in Earth orbit or in geostationary orbit, but even out to, say, meter-sized stationary debris in cislunar orbit. So really impressive capabilities for monitoring space debris and space situational awareness. Space and atmospheric sciences would like to be able to take the decades worth of data that we have that are location specific for Puerto Rico and combine that with new, even better data from an improved ISR and HF. And that'll give us really a tremendous opportunity because we have so much data and it can be used in combination with new results to really assess and investigate characteristics of global climate change. And finally, in radio astronomy, what I personally think is one of the most exciting capabilities that we hope to achieve is the possibility of studying exoplanet detection and habitability. And not only exoplanet detection, but habitability itself is what I find so exciting because we're sort of pushing past just this ability to find exoplanets now and actually looking at whether they could be potentially habitable. And radio telescopes are perfectly well poised to do that in a lot of different ways. And we think that we could contribute greatly to that. So I'll just end by saying thank you. We'll be happy to take your questions on any of the science that you're interested in. We actually have a whole panel of world experts here in each of these fields. So it's not just me. We will get all your questions answered. But yeah, thank you so much.
Thank you, Dr. Smith. Very impressive. Now we're going to have Dr. Carlos Padilla.
Thank you for the opportunity to talk to the committee, and thank you for the students that came today to show how important is STEM education in this site. This visitor center, we used to receive more than 85,000 visitors a year. Around 30 to 40% of those visitors were students from the public and private schools in the island. And we were very happy to receive these students to visit our center and to see how they changed the perception of science when they visit the site and when they go to the terrace. When they went to the terrace, there was the wow moment because they see that structure made by us and all the research that has done in Puerto Rico by all these scientists that are here. So we were very, very proud of this visitor center. We want to thank you, Fundación Ángel Ramos, for putting together this wonderful place that we can do all the work in informal education. I'm going to show you some of the samples of the type of education, informal education that we do here in these facilities. We have the STAR teachers. The STAR teacher, last year we could not do it physically here because of the pandemic, so we did it online. And we have more than 700 teachers that connected to the workshops in space science, chemistry, and biology, nanotechnology. So there is always people interested in this type of science. And we have also trained a lot of teachers on how to use this field research facility before they come to visit the site, during the visit, and after the visit. So when they come here, it's not like a field trip. It's really part of the science curriculum. Then we have the STAR Academy. We have many STAR Academy, but this one we have been building from all the experience from the last 10 years, having students from high school at our institution, and they spend here the fall and spring semester doing research. They come on Saturdays. We used to call it Saturday Academy. Now we call it the STAR Academy. Usually we have between 25 to 5 students last year. Because the pandemic, only 19 finished the project. This year we have more than 100 applications for next year. We already selected 35 students that are going to participate in the next START Academy. Girls Educating Girls, that's sponsored by the Puerto Rico NASA Space Grant. We had funding to fund only 4 students, but we got 188 applications. Therefore, we developed a volunteer program that they are participating, developing these curriculum, educational models for our curriculum in science. We had their REU students, the research experience for undergraduates. We are the site that received more applications of all the REUs in the United States. And we select the best students to participate in these activities, and all of them come here to the site. They spend 10 weeks on site. I think we still have one of the students, an REU student here on the public. Thank you for coming. They just finished yesterday. They did their presentation, and they're going to present this research on the major conference in the United States, hopefully, well, now that they're going to start. Then we have this is an outstanding observation nights. Observation nights are activities for the general public. These are, the whole family comes to these observation nights. Usually we get around 400 people to show in these activities at night here. One night, we received more than 1,000 people that came to this site to have this type of experience. Now we only limited to 400 to 500 people, and we increase, instead of 4 times a year, we are doing 6 times a year. Well, we used to. Hopefully we're going to start again. Let's put this in numbers. And here you have a graphic that I hope shows how important is this site for STEM education. We have more than 375 dissertations, PhD dissertations, mainly from the States, that have been using data from Arecibo or have been conducting research at Arecibo. We have more than 2,000 peer-reviewed publications using this site. We have over 300 yearly users from 250 institutions around the globe. We have broad government agency interest in this. We have more than 1,000 students that have participated in these academic programs. We have more than 600,000 visiting students at the Science and Visitor Center, and we have more than 1.5 million visitors since we had this Science Center. Our goal is to continue promoting the excellence in science education through our Science and Visitor Center. Our educational programs promote critical thinking, problem solving, passion for learning, discovery, the skills that are required for the challenging times. The contribution of science and technology to the economy cannot be overemphasized. The future belongs to science and technology, and Arecibo wants to participate, to continue to be a key partner in this national agenda. And these are some of the projects that we're thinking for the short term in this Science and Visitor Center. Thank you very much.
Thank you, Dr. Padin, and thank you all the witnesses and panelists for your information. Now we're going to begin the process of questions from members of Congress, and I hope we can make some times to do a question from the audience as well. But we are time limited, so let's begin with the chairman, Mr. Frank Lucas.
Thank you, colleague. Mr. Ebersol, you mentioned that you'll be submitting your report to NSF in September for review. So my question actually is, can someone from NSF please explain what this review process will entail? I guess you lucked out.
So our plan is to look at the report and then hand it over to a National Academy's set of, a National Academy study. So this is input into a National Academy study looking at, independently looking at from the outside, the causes and the lessons we can learn from this report.
Along with that, just one other question. Will you be amending the report before it's publicly released?
I don't think so, no.
Thank you very much. Yield back, Madam Chair.
Thank you. Now, for your time of questioning, Ranking Member Waltz.
There we go. I'm not sure who to ask this question of. Francisco, perhaps you or Mr. Smith from the National Science Foundation. I'm still unclear past this report. What's the timeline, or at least the rough steps of the process to realize the vision that we talked about today? That part I'm a little bit unclear past the end of this year. Once we understand what happened, why it happened, and that folds into, I guess, a broader report. I mean, right now, my understanding is China has this capability with its FAST telescope. We no longer do, and really, many ways, the Western world no longer does. So what are the broad steps to get back to an operational telescope here, or radio telescope here? What needs to happen? And then how can Representative Palazzo help you make that happen?
Sure. So I'll speak to, from the concept perspective, I'll definitely let NSF explain their regular review process and their typical process. But I think one of the major items is certainly the availability of funding, right? So making sure that the funding is available to begin maturing the project, right? And to beginning conceptual designs and environmental studies and engineering studies and so on and so forth. The real question, I think, goes into what is the avenue to really go make that happen, right? And what are the different possibilities of doing it? The way the National Science Foundation works, and I'm kind of speaking on behalf of what I know from the NSF process, so I'll pass on the mic here real quick. There are typical calls for major facilities, like an MREFC call, right? Major research infrastructure call. But those are capped in funding. There's a lot of requirements in order for a project to really be able to even be considered there. And so maybe you want to speak a little bit more about that, Chris, and how NSF envisions this process. You talked a little bit, I think, about receiving proposals and evaluating them, and understanding that would be useful.
So the perspective from the NSF is, first of all, we want to hear from the community. We want to actually take this broad stroke, this opportunity to take a broad look at what will be best, not only technologically, but also for the other aspect that we've discussed today, the broader impacts on the community, and bringing STEM education tightly into whatever solution we come up with. So we're bringing those ideas together. Some ideas, as Luis referred to, may be short-term solutions, and those we may be able to put into place in kind of year time scale, depending on the proposal process. Some may be the big ideas or long-term solutions. Those will have to go through a design process from concept to proposal, from proposal through our major facilities funding process. So those are the kind of two extremes. When we started the workshop, my boss, the Assistant Director of Mathematical Sciences, actually provided a list of funding opportunities that have all these scales. So some of the scales are proposals on a one-year time scale. Some of the scales are proposals that will take many years to develop a large, something that looks like the large vision that, that may bring a world-class facility back to see where we are today.
What initiates that large scale? Is that initiated from here, or is that a request for proposals that NSF puts out? I'm just, we've spent a good amount of time here today and it's been fantastic, but I'm finding myself somewhat at the end of it, still a little bit confused on the path forward past the end of this year. I mean, I understand the different broad possibilities,
Right. So that's the scale.
but if we're going to go, say we're going to go to the think big, dream big,
right.
And from what I see is we have a capabilities gap that comes from NSF.
No, that comes
My
from
time's up.
Yep,
Chairman
sorry.
said I'm done. No,
Comes
I'm
from the
kidding.
community.
Yeah.
Short answer, comes from the community.
Well, no, I'm saying, I was joking. No, I'm saying, is that a request for proposals from you, from the NSF?
Our
or-
major facilities are usually come out of the community prioritizations
Uh-huh.
and the community proposals that come to us.
Okay.
And those are usually not timed for solicitations. Those are usually come in and we look at that, given the prioritization, the community recommendations that they give us from things like the Astro 2020 They Go survey, but not only those, other broad community prioritizations.
Thank you. Congressman Babin?
Thank you. Appreciate it. Actually, I have several questions, but I know we don't have much time. But in March of this year, Lindley Johnson, head of NASA's Planetary Defense Coordination Office, stated at a meeting of NASA's Planetary Science Advisory Committee that NASA wants to be involved in what the future of the Arecibo Observatory can be. He also indicated that NASA is in preliminary discussions with the U.S. Space Force about how a rebuilt Arecibo might support their efforts, something those in favor of rebuilding have already previously proposed. What type of capabilities could the Arecibo Observatory enable for our Space Force? Who would like to answer that?
I can probably answer that one, since I'm a former NASA guy. Lindley, works in planetary defense.
Right.
And so we had a big role in characterizing the orbits, the rotation of, potentially Earth-killing asteroids. So that's one thing a radar system can do for you. The other thing that could be done with a powerful radar is obviously things like detect satellites that don't want to be detected. It can detect, arcing off of satellites, so you can get a much better picture of what is actually orbiting the Earth, whether it be debris or active satellites. So I think that's really, NASA's focus when you look at things like the International Space Station that are particularly susceptible to orbital debris, micrometeorite damage, but also things like, and I'm pretty sure you're familiar with this, even paint from that comes off
Flecks
of
of
rockets.
paint can be dangerous.
Right, those little particles are moving at orbital velocities, and so they, even though they're fairly light, they're moving at such high velocities that when they impact, thin metal structures and pressurized metal structures in
Damage
space,
can happen.
they can cause quite a bit of damage. So I think that's really the kind of applications NASA's looking at.
Okay, and then has NASA or NSF studied potential public-private partnerships as a way to rebuild and modernize the Arecibo Observatory?
So I'll answer one piece of it. We have talked to a lot of private foundations about, potentially contributing to some kind of an effort here at the observatory. But I think, based on our conversations, that private partners are really looking for the government to show a lead because they can't carry the water on their back. But I think we could encourage a lot of private investment if there was some kind of plan and commitment by the government. But anyway,
Okay. Sure.
I would say, we're working with NASA, we're working with Lindley on understanding the requirements that NASA would need for that sort of thing, and then pursuing those conversations into what might be implementations.
Okay, thank you. And I don't know how much time I got left, but since the collapse of Arecibo and its main telescope, are U.S. researchers now using the Chinese government's 500-meter fast array telescope? And how much time has been allotted for foreign usage of the fast array telescope in China? And what are the ramifications of that? Yeah.
Yeah, the state of Florida, our governor, we have legislation in the state of Florida that we cannot collaborate with Chinese scientists. So because this is under the operation of the University of Central Florida, and there's also federal law that prevents us from collaborating with China, we are not currently, none of our science staff is collaborating with China on any active investigation. So, I mean, from our standpoint, that's kind of the answer, but
And we think that's good.
Yeah, and so that I completely agree with what Ray said. I will add that we do know that some of our users are now having to go to China and request time at the FAST telescope to continue their research process. And so the ramifications and impact of that are significant, because at the time, the current way that FAST is working, they require there to be a Chinese national to be part of the project. And so you'll have U.S. scientists doing the research, and then you'll have partial credit to their Chinese collaborator for supporting the efforts on their telescope.
but they also end up owning the data sets, so then they can do with those data sets what they want. So
You told me this earlier today, and I wanted to make sure that.
yeah,
got
that
in.
is,
Yeah.
I want to be clear on that, is when they're a collaborator, they have the data just like we do. So if a U.S. scientist is collaborating with a Chinese scientist
Right.
using FAST, the Chinese have the same data that the U.S. scientist has.
Thank you very much. I see my time's expired, so Madam Chair, I'll yield back.
Babin, now Congressman Palazzo.
All right, thank you. What risk does America run if we do not replace this observatory with equal or greater technological capabilities? And that's
I can be fired easier. I'm older and closer to retirement. So first off, I want to make absolutely clear that I'm speaking on behalf of myself as a private citizen, not for the National Science Foundation or for UCF. But I would share with you from my standpoint what we lose as a country not having a facility like Arecibo. First is the inspiration to students here on the island to do, to pursue an education first, not necessarily just STEM education, but an education. And then more importantly, great nations invest a percentage of their GDP in basic research. And that's one of the things that kind of separated the U.S. from the rest of the world, is the investments we made in basic research. Some of it has military applications, but even that research typically drives economic activity, investment in products and services that really help keep us on top economically. And really our safety and security as a country really relies upon us not only being technologically strong, but also being economically strong. So from my perspective, it's it's trying to maintain leadership in science and technology that helps drive our economy and keeps us on top.
That was a good response. Of course,
It was. I was going to say, that was a good response.
Yeah. And I liked Francisco, your comments about, you're not shooting to be evolutionary, but revolutionary in whatever replaces the current observatory. If you were to get your wish, and I know it's still in a design that hadn't even probably begun. Maybe you do have some back of the napkin type ideas, but how long would it take to replace the current observatory, which is down with what you would like to see replaced here?
So I think it really depends on how quickly and how the review process is going to work. And I want to be very clear about that. Typically, National Science Foundation's MREFC processes for large facilities take 20 to 30 years. Okay, so if the strategy and the plan, and I'm not saying that is, I'm just saying if that is the strategy and the plan to go through that particular process, that requires input to the decadal survey, community support, and it requires then multiple iterations of design development phase. And that's what it takes to do these type of facilities. If we were to say, hey, you've got here X amount of money here right now, you can go start building this telescope because we believe is an important thing for the country and for the world, I would say anywhere from 4 to 7 years would be the timeline to do the design and construction of the telescope.
Well, thank you for that. That seems like a lot of time and a lot of loss to our country for not having the just those capabilities that y'all described so well today that we absolutely need. Our very survival could depend upon it. And as we know, space travel is not going to decrease, it's only going to increase, and the mega constellations of satellites are going up, and some of our adversaries blowing up things in space and creating debris fields. It's just so important. And if I could, if there's a way to get some of the PowerPoint slides that everyone had up today, that would be fantastic.
And we will make sure to get copies of everything.
Thank you.
Yeah, we'll make sure we get it to Representative Colon's office and she can distribute it to the room.
Fantastic. Thank you. I yield back.
I'm going to be brief because I want to have at least 1 or 2 questions from the audience. But my main question is going to be to you, Francisco. I think after what we saw of Dr. Smith's presentation and, of course, the visit of the site, what are the capabilities of a next generation telescope can have to surpass the China's fast radar? I mean, specifically, what can we invest and how much do you think does that technology may cost in different phases to the program?
So the concept that we've outlined for the next generation Arecibo telescope is very specifically designed to be, again, revolutionary and to surpass the capabilities not only of the Chinese fast telescope, but really of any other radio telescopes in existence right now. And so sensitivity is one of those, right? So we would be certainly more sensitive than they are currently, which means we can see farther into space or see in more detail if we were closer. And the radar capabilities that I mentioned, right? We're talking about something that has never been seen. An 8 megawatt radar doesn't exist. A 10 megawatt radar doesn't exist in the world. So they'd be first helping us maintain the leadership. We've done rough order magnitude estimates on approximate cost of such an instrument. Of course, there is detailed design that needs to happen in order for us to really be able to hone into that number. But we believe it's in the approximate $500 million range.
The other thing that's maybe different about this concept, and I want to be clear, it's a concept, and I do not expect that what you saw as a pretty cartoon up there is necessarily what it will be. But the intent was to use hardware that currently exists. And the reason that's important is because most projects have cost problems because you're trying to push the state of the art with technology. And we believe there's existing technology out there that can be brought to bear right away and give us a capability. But the beauty of it is it's a modular system, so it can be upgraded over time for a lot less cost than what we see, typically on systems like that. So.
And real quick, one other thing I forgot. This concept actually moves, right? So it will allow us to see over 250% more of the sky that we would see on the all 305-meter telescope, which is the same problem FAST has. FAST, they don't move their telescope, right? It's very similar to what we had here because they sort of copied our design. And so,
No kidding. But thank you. I want to say thank you to all witnesses for what you've done with us. I do have many other questions, but I'm going to submit it to you in effort to maintain the timing. But I will want to take at least 2 questions from the audience. So just need to raise your hand, and we could going once. Go ahead. Identify yourself, where you come from, and the question.
Hi, my name is Hector Arce. I'm a professor in astronomy at Yale University. I originally from Puerto Rico, and I was inspired to go into astronomy thanks to the Arecibo Observatory. And well, this is more a comment than a question. Thinking of what Representative Mike Waltz said. Well, first of all, let me thank you for taking the time to come all the way to Puerto Rico to come in person and visit the site. But thinking if you really think that this is very important to have a facility that does all the nice things that Francisco and all the other people here talked about in science and STEM, well, there are opportunities, I think, in Congress to, put it in writing, to specifically say, that the U.S. should put forth money to design and construct a new facility. So right now, I guess the Endless Frontier Act would be a good opportunity for doing that. And the other comment that I have is that, it would be great to also have the Puerto Rican community, the scientists, the radio scientists and engineers to be involved in the process. So those are the important things that I think should be kept in mind when talking about this. So thank you.
Thank you. That brings me to a question to Francisco. The Next Generation Telescope got support from the community, from the local community and the local academia?
Yes, so we have over 3,000 endorsements for the Next Generation Arecibo Telescope concept. It also includes official endorsements for each and every one of the higher education institutions of Puerto Rico, so University of Puerto Rico, Universidad Interamericana, Polytechnic University, Universidad Ana Jiménez. They have all officially endorsed the support for their concept.
Any other question? Please raise your hand. Going one, twice, no questions? Okay, go ahead.
Well, real quick, I know in 1974 y'all sent a coded message into space, and so did anybody respond or anything? Or is that classified? Can we not talk about that? I'm sorry, Chairman. You know I was going to. Anyway, no, thank you.
You're on my live stream, remember?
Any answer? It's classified. It's classified information, Mr. Palazzo.
We can bring out the alien. He can tell you.
But having said that, I want to say thank you to all of you for coming here to participate in this forum, and for the especially brilliant panelists that we got today, and for enlightening us about the situation of the observatory and what can we do to help the observatory. And I want to thank again Chairman Lucas and the rest of the members of the delegation for coming to Puerto Rico just exclusively to do this. I think that's important, and we need to recognize that even when Congress is now in recess, we do have 5 members of Congress coming to Puerto Rico just to look at this. So a big round of applause to members here on the island from Texas, Florida, Mississippi, and Oklahoma. And I'm really grateful. And again, thank you to all the volunteers, all the people working here, all the staff to the observatory. And again, thank you for supporting this. And we hope that we can see, I won't say the light, I will see the stars in the near future here. Thank you, and have a good afternoon.
Thank you.